Videoing now, right? So, hey, Katie. Hey, Katie. All right. Okay, so we're finishing up 5.2 notes. So we're going to sketch graph. So this this is kind of a little weird kind of skill that we go over that the book doesn't cover it, but when I inherited this class from Mr. Schwab, he did it, and I think it gives a different perspective. So what we're going to do here is we're just going to sketch the graph of a function without being given the equation. We're just given information about the first derivative. Okay? So it's really just kind of looking, instead of us finding out all this stuff like we did to sketch our graphs for homework, instead we are just looking at the results of that and going to sketch a graph from it. Okay? So we have to figure out what information it's actually giving us. So if we're being told that the derivative, so we have some f of x somewhere that we don't know what it is, some function. And here we're being told that the derivative of f of x at 1 and the derivative at 4 equals 0. What does that tell us if we're going to sketch a graph of this function? So what do we do with those numbers? Yeah, x is 1. When x is 1, y is 0. And when x is 4, y is 0. So what do we do with 1 and 4? They are two what? On the number line, right? And what are they called officially? Critical numbers. They're possibly max and mins, right? So the fact that this is telling us that the derivative is 0 at 1 and 4, that tells us that 1 and 4 are critical numbers, right? Because that's how we would define them if we were given the equation. Okay? All right, now we're told that the derivative of f of x is greater than 0 when x is greater than 1 and less than 4. So what does that tell us? Right, the middle section is positive, exactly. Right, so if the derivative of f of x is greater than 0, so that would be the same thing as like I chose a number, plugged it in, and I got positive, right? And that happened for the x's between 1 and 4. Okay, and then it says that the derivative of f of x is less than 0 when x is less than 1 and y is greater than 4. What does that tell us? Exactly, the left and right are negative. Okay, so what's happening at 1? It's a min, right? Because it's going down and then coming up. And what's happening at 4? It's a max, right? Because it's going up and then coming down. So now we can sketch a graph of this function without ever having the equation. Question? Oh, okay. All right, so now it tells us f of 1 is negative 2. So what does that tell us? Right, when x is 1, y is negative 2, of which equation? The original or the derivative? The original, right? So this is telling us when we draw this min and max, these are the values we're graphing, right? So when y is 1, x is negative 2, so we have a point, 1, negative 2. And when when x is 4, y is 1. Okay. And now, how do we connect them? Coming in here, are we coming up or coming down? Down, right? So now we can draw the graph down, then up, and down. Okay, so it's just kind of making you think really what it means when you find out this stuff, right? Questions about that? All right, I want you guys to go ahead and do the next one in your notes. Okay, so if we look at, okay, so again, this tells you if the derivative at these values is 0, then you've got a critical number at -3 and 2. This is saying it is negative between -3 and 2, and then positive, so you've got a max and then a min. Everybody agree with that? Everybody good? Okay, so again, just kind of, I thought it was a kind of a neat perspective to kind of work backwards on that. So, so part of your homework is on your half sheet. Is, actually, let's go and do this. Go ahead and do that. We'll take it off homework, but I'll give you, because we got, the next notes aren't going to take a ton of time either. So this way, go ahead and get your half sheet out and sketch 5 through 7, and we'll look at them when you get done. Okay, so if we look at these, again, positive, negative, positive, so min and a max, a max and a min. Several of you were a little confused on 6, and really what I found, I don't know if it's, I don't know what it is, but it's interpreting the less than greater than signs. Do you all have a hard time with that? Like, that's where I found the most struggles with, is just knowing, like, how to interpret those signs. Does that make sense? So, again, I don't know how grade school teach it, but the smaller part, I thought this is less than 0. Like, you're reading it kind of left to right.
I think you can do those multiple things
Okay.
It's going to say,
like this gonna
hopefully keep everything straight.
Yeah. Okay, I can see that.
Just kind of a dumb way to say it, but think of like the greater than or less than signs with like an alligator. It wants to eat the one that's bigger.
Okay. Okay. So is that all right? So by thinking about that, you can tell that this means negative then, right? Because so that means the negative eating the 0.
Yeah.
But, okay. Yeah, that would be horrible to teach you grade school, because I'm not good at that.
My dad just told me like
Yeah.
Okay, what else?
Yeah,
Yeah, I think of like this is like the bigger part, so it's greater than.
I mean, I don't know, but I can just vibe that's like the greater than and thinking about the same thing.
So I was like, okay, 2 has to be what, so if 2 is -2, that has to be the min.
Well, oh, you mean down here?
Yeah, and like, I feel like.
Oh, be careful about, okay, yeah.
Always going to be something negative.
Right. Yeah, be careful with that, because you really do need to know how to interpret these. I guess my thing with the alligator is so this is this is greater than 0. So with that alligator now, you know that everything greater than 0, like anyway, I guess I don't even understand the alligator.
I was going to say, I just read it. I just put the X over the because like when you look.
Well, that's what, yeah, I was going to talk about that too. So on these, so you can definitely think about it as 2. Like, it's usually, anytime it's written like this, it usually means everything in between. But you can definitely think about that as X greater than 3. Yeah, greater than -3 and X less than 2. Okay. I just, like I said, I don't understand a lot of the grade school like analogies and how to explain that stuff, but I've noticed that people have a hard time with that. Okay, and then the last one, I just want to talk about 7. It just gave you just an extra piece of information, right? When you were looking at 7, it told you all this, and it told you f of 2 is what, -3, f of 5 was this, but then it also just told you f of 0 was 2. And that was just giving you the y-intercept just to help you make a more accurate graph. Does that make sense? Okay, so that was just kind of, and again, one thing I like about that worksheet is it's just trying to help you kind of get used to the notation also, like reading a bunch of symbols without actual words. So do you do okay on those? 5, 6, 7? Okay. All right, so that took off half your homework. So the rest of it is, so we're going to start chapter 5.3 now. And 5.3, actually, we're going to be having a quest after chapter 5 after 5.3. So I split 5.3 into two parts. So we're going to do part 1 today. So that's the higher order derivatives, which sounds very official. And then we're going to do concavity. What's today? Wednesday. Concavity on Friday. Then we will be testing next Thursday. Does that make sense? Or questing. So as I talked about before, this whole semester seems like more a little test. So is there any big thing going on? We start before we got the class. Right. Oh, it's off Monday. Yes, it'll be Friday. I forgot everyone to do that. So chapter 5, part 1, Quest, is Friday, and what's the date on it? Okay, yeah, so we'll finish this little part of the chapter on Friday, this Friday, and we'll test it. Okay? That's the one good thing about G-Block is we never had to worry about short days. So, okay, so the first part of chapter 5 of 5.3 is higher derivatives. So, and these are not too bad. I mean, we're going to make them bad here for a little while in a second, but these are just taking, instead of just first derivatives, so first derivatives tell you some things about a function, right? Like we saw where it told you increase and decrease, we can find max and min. Well, the deeper you go into derivatives, to a certain extent, you can find more information. So we're going to start with this function. So this is our f of x. And we're going to take the derivative of f of x. So that is what's considered now our first derivative. And again, so if we take the derivative of f of x, we get what? 4x to the third plus 9x squared plus 20x. Now, for even more fun, we can take the derivative of the derivative, and that is called the second derivative. Okay, so the first derivative was the derivative of the first equation, of this equation. Take the derivative of the first equation, and it's called the second derivative. And again, the notation for that is just two of those little, whatever they are, apostrophes, whatever. And now you're just taking the derivative of the derivative. So we get the derivative of this was what? 12x squared plus 18x 20. So that's the second derivative. And then we can keep going and take the third derivative by taking the derivative of the second equation. The third derivative would just be three little apostrophes. And take the derivative of the second, which would be 24x. And if you notice on a polynomial, every time you take a derivative, it goes down 1 degree. So that's the third. And then we could even take, you could go as far as until the equation runs out. We can even take the fourth derivative, but on the fourth derivative, they run out, they don't do it anymore. Just note it was a little 4. So the third derivative of the third equation is the fourth derivative. I think it's 24. Fascinating. Now, to be honest, we are going to next class we're going to use the second derivative to find out some things about a function. We really aren't ever going to use more than that, and I'm not sure. Later calculuses might. I'm not sure, but so. When you're taking the derivative, the same rules apply, and the same notation can be used. It's just you're substituting the ones for twos, right? So you have 2 hash marks there, and on this other notation, you just use a little 2 instead of the 1. Okay. All right. So what we're going to do is just take some derivatives. So so for instance, on this one, it says find the third derivative and the fourth derivative. So actually, you guys go ahead and do that. Not in the mood to talk today. Okay, so again, on polynomials, they're pretty easy, right? Just keep taking derivatives, and they get actually simpler and simpler. Now, not so much so for some of the more complicated ones. So just to kind of make sure we don't get complacent in our derivative taking skills using other rules, let's go ahead and take the second and third derivative of this function. So these are not polynomials, right? So to take the first derivative, what rule am I going to use? chain rule, right? So what's the first thing I'm going to do here? Bring 2 down, right? And then keep the parentheses. Put it to the first, and then what else? Which would be what? 2x. Right? And then I simplify all that, and I get 4x times x squared minus 1. Very good. Now, if I want to take the second derivative, I'll tell you what, we could distribute in, right? But just to practice the product rule, oh, what's going on with my thing there? Just to practice the product rule, let's keep it separated like this, okay, to take the derivative. So the product rule tells me what? Who can tell me what the product rule is again? Okay. What's the product rule?
Is it like plus the derivative of the other?
Perfect. Yep. I mean, different words than I use, but
Yeah.
absolutely. Okay. So first, so derivative of the first is 4, right? Times the entire second, or the normal of the second, so x squared minus 1. And then plus derivative of the second is what? 2x times 4x, right? So if we simplify that, so now we can distribute that 4 inside, right? So we get 4x squared minus 4 plus what? 8x squared, right? And then we combine like terms, we get what? 12x squared minus 4. So that's our second derivative. And then our third derivative is what? Yeah, just 24x. So actually that wasn't too bad. Okay, everybody with me? Right, so you did what? Yes, so you did 4x to the third minus 4x. Yeah, and then got 12x squared minus 4. Yep, same. I just wanted to practice the product rule a little bit, okay? All right, everybody with me on that? Okay. Let's do this one. So again, I purposely put this one in there just to kind of practice a little bit of our ln x rules. I will give you a little cheat sheet. So remember, derivative of ln of x, you might remember what it was. You all never did have to memorize it, but yeah, so it's actually the derivative of the top over the bottom, but for just ln of x, it would be, no, sorry. Actually, nope, you're right, I wrote it wrong. So actually, if it was derivative of, like, g of x, it's g of x on top and derivative on the bottom. So for ln of x, it's actually just 1 over x. Okay? Remember that? Okay, so on this one, though, what do we have to do? If we want to take the first derivative of 4x times ln of x, we have to use what rule again? Product rule, right? Because the first function would be 4x, the second would be natural log of x. So the first derivative, so what's the derivative of 4x? 4 times just ln of x, right? Natural log of x, plus derivative of the second, which would be 1 over x, times the first. Okay. Now, how does that simplify? Can we do anything with this first term? 4 ln x? No, right? That stays. What can we do with the second term? Right, or when we multiply these, what happens? the x's cancel, right? Because we end up with 4x over x, so the x's cancel, so we get plus 4. So that is our second derivative. I mean, our first derivative, sorry. Okay, so I'm taking the derivative of this, okay, and I'm using product rule. Yeah, so this is a function, 4x, and this is a function, ln of x. Okay, that makes sense? Okay. All right, so that's the first derivative. Second derivative. So do we need to use the product rule now on 4 ln of x? No, why not? Because there's no derivative. I mean, there's no variable with that 4, right? So, I mean, you could use it, but the derivative of the first would just be 0, so it kind of wipes out that whole first piece of it. So the derivative of 4 ln x is just going to be what? Remember that? So 4 ln of x, we're just really going to keep that 4 out there and take the derivative of ln x, and it becomes 4 over 1x. And then derivative of 4 is 0. So actually, second derivative is just 4 over x. Okay, now we need third derivative. What do we want to do with third derivative? What's that? So rewrite it so it is actually 4x to the negative 1, right? Everybody with me on that one? And then we take the derivative, so we bring down the negative 1, we get negative 4x to the negative 2. So rewrite that, we get negative 4 over x squared. Okay, that makes sense? All right, so, okay, again, that's 3 derivatives. All right. Now we got one more. This is kind of the doozy of all of them. So here we're only going to do first derivative and second derivative, okay? I mean, it's only asking us for second derivative. Okay, so I really put this on to kind of review. And then, in this notation, this just means second derivative at 0. So you're going to take the derivative and then do what? Plug in a 0, right? Take the second derivative, plug in a 2. Okay, so first let's take first derivative. So we're going to rewrite this, right? So we get 2x squared plus 9 over 1 to the 1/2. Taking the first derivative, again, we use the chain rule, right? So we're going to bring in the 1/2. Keep the parentheses the same. And now this goes to what power? Negative 1/2 times what? 4x. Okay, now so final answer, how do we clean that up? What's going to go in our numerator for the final answer? Just a 2x, right? Because these are going to cancel. That makes sense? So we're going to get a 2x on top and a 2x squared plus 9 to the 1/2 on the bottom. Everybody agree with that? Okay. All right, now, second derivative. Well, no, now we have to take the second derivative, sorry. So we don't need the first for anything except to get to the second, right? Because we're taking the second derivative at 0 and 2. Okay, so now second derivative. So now what rule are we going to use? Quotient rule. So quotient is, what goes first? Derivative of the top, which is going to be a 2, times the whole bottom, or the whole denominator, I shouldn't say bottom, really, it's not technical. And then minus derivative of the bottom. So that is going to be what? 2x squared plus 9 to the negative 1/2 times 4x, right? So that's minus derivative of the bottom times the top, right? Are you with me on that? So that's, again, that's, and then we don't want to forget our all over the bottom squared. So actually 2x squared plus 9 to the 1/2 squared is going to be what? Period, right? Or to the first, yeah. So squaring the bottom just makes it a 1, right? Okay. Everybody good so far? All right. Now, though, here's what, so we've still got this 2x plus squared plus 9 to the first. When we simplify the numerator, we get 2 times 2x squared plus 9 to the 1/2. What happens on this second part? What do we have to do is we clean this up. What do we have to do with this negative 1/2? Move it to the bottom, but because if we need to move it down here to the bottom, we're actually making another layer in our numerator. Does that make sense? In other words, because of this minus sign, well, let me write it out. This becomes minus 8x squared over 2 times 2x squared. Okay, so take a look at that. We've done this before, but we haven't done it for a while. That make sense? What? No? Okay, all right, so again, this stays the same, right? But this subtraction sign, again, is a big separator, right? So we can't combine any of this with that. So when we just simplify just this highlighted terms, this fraction sets us up with this 2 layers, right? So the 2 goes on the bottom. All of this, 4 times 2 is 8, x times x is x squared. That goes on the top. This just comes down to the denominator with that 1/2. Yes, we can do that. I didn't want to do that at first just because I knew this was going to be confusing. I didn't want to show too much at one time. But yeah, so right away we can, this actually just becomes a 4. Okay. Now what do we have to do? Focusing on just the numerator, what do I have to do? No, we're not worried about that at this point because we're just simplifying. What do we have to do to the numerator? What do we have here? We have a non-fraction minus a fraction. So we have to do what? Find a common denominator. Okay, it's okay. Don't be afraid. Okay, so consider this as like over 1, right? So what's our common? So just looking at what's circled in red, what's our common denominator going to be? 9 to the 1/2. So down here, I'm going to write 2x squared plus 9 to the 1/2 minus 2x squared plus 9 to the 1/2. Well, actually, I don't usually do that. Actually, oh, hang on, let me do this differently. Okay, so I need to write them both with 2x squared to the 2x squared plus 9 to the 1/2, right? All right, so let's do it this way. This already has that, right? This part is already over 2x squared 9 to the 1/2. So I can just go ahead over here and say minus 4x squared. So I just have to fill in what this would be. Does that make sense? Now, what do I have to do to make this have this denominator? What do I do? Multiply it by 2x squared plus 9 to the 1/2, right? So I'm multiplying top and bottom by 2x squared plus 9 to the 1/2. This just becomes this one, right? just gives me my denominator. What is 2x squared plus 9 to the 1/2 times 2x squared plus 9 to the 1/2? Just, right, just 2x squared plus 9, right? Because again, just the same way that we ended up seeing that our, that even squaring to the 1/2 became a 1, right? 2x squared plus 9 to the 1/2 times 2x squared plus 9 to the 1/2 just becomes 2x squared plus 9. So we have 2 times 2x squared plus 9, which becomes, which becomes 4x squared plus 18. Everybody with me on that? Let me show a little bit more. So this becomes 2 times 2x squared plus 9 to the first. And then when I distribute my 2, I get this. Okay, now all of this is still over our 2x squared plus 9 to the first. What's that? Is everybody okay? Y'all follow me on this? Okay. So we're almost there. What can we do to our numerator? Can we simplify? Right, so the 4x squareds cancel out. So we end up with 18 over 2x squared plus 9 to the 1/2 all over 2x squared plus 9. And think about it like this. So now what do we do? Keep change, right? So we got, basically now we have a fraction over a fraction. So we're going to say 18 over 2x squared plus 9 to the 1/2 times 1 over 2x squared plus 9. And our answer becomes 18 over what? 2x squared plus 9 to the what? To the what? Not the second, almost. The 1 and 1/2, which is what as an improper fraction? What's that? 3 over 2. Very good. Yeah, 1 and 1/2 is correct, but let's keep it improper just because it can look like 11/2 or something like that, right? So all we did here is we added, right? We added 1/2 plus 1 to get our 3/2, which is this. Yes, there could be. We've done this before, right? Yes. I don't do this for the fun of it. Yes. Let me tell you, but no, we are, if you all recall, we've done something like this before, and we will do it again second semester. So that's one reason I introduced this here, okay? And your homework might have 1 or 2 like this, okay? Again, though, all we've done, actually, we're not done yet, right? So we want to, after all that fun, we still need to do the second derivative, add 0 and add 2, right? So that's actually the very easy part, we hope. So the second derivative at 0 is going to be what? We plug in 0. No, well, because plugging in 0 for x is okay, which this term goes away. So it actually becomes 18 over 9 to the 3/2. Can anybody tell me what 9 to the 3/2 is, just by doing it in your head? 27. How'd you get that? I think so. You took the square root of it, right? So the 2 on the bottom of this exponent means square root, right? So it's taking the square root of 9, which is 3, then cubing it. I have no idea what I'm doing now. But it's kind of scary. It's not going to let me write. So that is, what did you say, 27? So it's actually 18 over 27, which is, this was the derivative at 0. So second derivative at 2 is going to be what? 18 over 2 squared is 4 times 2, 8 plus 9. 8 plus 9 is what, 17? Ooh, I have no idea what 17 with 3 halves is. I'm going to, am I going to calculate? Because you can't take a square root of it, so that's going to be a strange. 7.1? 70.1? Okay. Well, let me see how you do that. Sure. Oh, that's 70.1. Okay, so then 18 divided by that. It's actually 0.256. 0.257, rounding. So actually, this is 70.1. Did I say 0.256? Okay. With that, you just have to plug in the calculator. Okay? Questions about that? So, let me scroll. Yeah. Okay, so again, just on this one, it's just whenever you're making another layer, you know, in a numerator, and next one you've got to stop, take the numerator out, and get a common denominator for that. Okay, and there will be, I'll look at homework after lunch and give you all a heads up on which ones it's going to require. Okay? All right, so homework is just taking derivatives. So I think what this is really straightforward and something to find. Okay? All right.